Moving on to the second part of our physiological factors affecting performance, or specific physiological factors affecting performance. We'll move on to now environmental conditions and performance, so things like hot, cold, and altitude. So we start off again questioning how does the environment actually affect performance, and what are environmental examples. So key things that can impact performance are shown here. So our hot and cold, our temperature, internal and external, and our altitude. So how does altitude, this thing called altitude, affect performance, and what is altitude? So it's associated with oxygen availability. So here we can see this concept of sea level. That's where we tend to live in Whyalla, where we're right on the level of the sea, so the air pressure and air density is fairly controlled. So we're at that 100% level. So as you move up, you can see away from sea level, we can see that the air density becomes less. So what is maybe 100% air density here, it's only 69% there, only 60% there. So what is it telling us? That as we get further and further high into, say, mountains or above sea level, every breath that we take compared to sea level is only 60% of that concentrated oxygen in that breath. So our body has to be able to be more efficient in extracting the oxygen out of that breath. So when we're at sea level, we have that 100%. When we're at altitude, depending on the level of altitude here, we have a lesser percentage of concentrated oxygen in that breath. So how does it affect performance? Altitude has immediate short-term or acute short-term effect on performance. We have something called altitude sickness. So that means less oxygen coming into our body during activity or just normal rest or anything like that. So short-term effects of altitude sickness, things like fatigue, headache, nausea, vomiting, sleep problems, agitation, and vertigo, which is like a dizziness. So how does altitude positively affect performance? If we're talking about becoming sick, how can it actually help our performance? So how can it actually be used in training? So like anything, if you put your body under stress, your body will change. So altitude can develop important chronic adaptations when used as a training method. So if we do training at altitude, we can see these things happen. So an increased EPO levels in the body, increased exertion of human growth hormone, increased ability to use fat during an endurance activity, increased ability of the muscles to get oxygen out of the blood, increased VO2 max, increased red blood cell count in the blood, increased plasma volume. So with your knowledge of chronic adaptations to the body, we can see that if these things are happening by training at altitude, we're going to see significant increase in performance, just like these ones here all relate to being able to get more oxygen to our muscle cells, more aerobic respiration. Therefore, we can work at a higher intensity aerobically without having the effect of fatigue. Things like this, increase growth hormone, can see increase in muscular hypertrophy, again, which used in endurance athletes can mean that we have more mitochondria. So, how does altitude training methods change? So we have this concept called live high, train low, or high low is a popular altitude training regime. Basically, we can see here athletes live in altitude conditions to get the exposure to these conditions to help create these chronic adaptations. This is the high, and then they move down and train at sea level to be able to get the volume of training they need. So they might just live at altitude to be able to see those adaptations happen to aid that oxygen delivery at rest. And then if they increase their volume at training at sea level, then being able to get more oxygen in, they can train at a higher level to be able to then improve the performance. So instead of actually training at altitude, where you might only be able to train as hard as the oxygen you can deliver, if you can deliver more oxygen at sea level with the altitude adaptations already there, you can have a greater physiological output. So, how does altitude improve the performance of team sport athletes? So, two key factors that will improve by altitude training include: one, the stimulation of EPO that leads to an increased delivery of oxygen to the working muscles during activity, and two, the increased ability to buffer the buildup of lactic acid during high intensity activity. So we know that any increase in performance for particularly an aerobic style athlete reduce the lactic acid and stimulate oxygen at the muscle cells will allow us to increase that team's athletic performance. So let's explain how oxygen delivery to the muscles during a game would benefit the performance of the athlete. So we know, again, just with our general answers, talking about being able to work at that higher aerobic intensity for longer. So let's see what this person has to write. So team goals involve a high intensity, efforts of high intensity and low intensity. During high intensity, the anaerobic systems are used. During recovery, increased oxygen delivery allows for the rebuilding of key fuels. So they're talking about recovery. So the second question, explain how the ability to tolerate lactate acidosis would benefit the performance of a team athlete during a game. So we know, again, without being specific to this, the tolerance of lactic acid will help that athlete being able to push at a high intensity for longer during that team performance. So multiple high intensity efforts. So let's see what's the answers given here. As stated, during high intensity efforts during the game lasting more than 10 seconds, lactate acidosis builds up. In a team game where repeated efforts are often required, it is the ability to run a high intensity effort for a prolonged period of time. The ability of muscles to tolerate this lactic acid and still maintain performance is an advantage. For example, in football where a player chases an opponent, laying his tackle, then required to do a similar effort again and again. Okay, so just a case study here, altitude training, middle distance running in an elite athlete. So the graph below shows the effect of altitude training, live high, train low regime on the maximal oxygen uptake of two athletes, A and B. Both athletes were elite 3,000 metre runners and competed in a 4-week training program. So let's look here. 3,000 metre time is what I'm showing on that axis. So post-altitude training, we're looking at significantly less than pre-altitude. So pre-altitude training there was 9 minutes 32. Then after altitude training, we're looking at 9 minutes 26. Here, dropping 4 seconds. So we can see that there's been a significant time decrease from that altitude training. 4 seconds, could be a 40, 50 metre effort. All right, now we're looking at environmental considerations, temperature and performance. So how does temperature affect performance? So temperature affects performance on two levels. So heat produced by body functions such as muscle contraction. It looks at internal temperature factors and the heat and cold from the environment where activity is undertaken. So that's external. So we have internal temperature factors and external temperature factors. So how causes changes in temperature during performance? So a number of factors have impact on the internal heat production during activity. So things like the duration of the activity, the muscle groups used, the intensity of the activity, the training state of the athlete, so the fitness and health level, and the capacity of the athlete, so the workload tolerance, which is obviously different. So those things will impact on internal heat production during activity. So we can see here the body has a number of mechanisms that help to get rid of heat. I won't go through all of them because I haven't got time in the video, but if you need to have a look at them closely, please pause and read through and note as required. So again, how does the body get rid of heat and why does it need to get rid of heat? The body needs to get rid of heat because of a balance and its effect on performance. So it has heat loss methods and to try and balance out the heat gain. So the friction from muscle activity, heat from metabolic reactions, it has to lose that heat through some methods. One of the key ones would be the sweating. So chronic effects of heat training. So how does heat actually training affect in a positive sense that athlete? So it can lower core temperature at the start of sweating, increase heat loss by better blood flow, increase plasma volume, decrease resting heart rate, decrease the core temperature in the body, alter metabolic fuel use, increase oxygen consumption, adaptation to exercise in a hot environment and in a cool, cool environment. So those things can be adapted through training in hot or cool conditions. So how do cold environments affect the sporting performance? So the body functions affected by these processes. The core temperature falls. So what we happen, and if we get too hot as well, and we get too cold, we lose motor skill control, and which is affected. We follow by that irrational behaviour and thinking, an inability to walk, and eventual loss of consciousness, and even death. So we can see, even just on that first level, if we're involved in a team game and we're not adapted to either cold or hot temperatures, our motor skills and our decision making are the first things that suffer. Can pollution affect performance? Air pollution can and does have a negative effect on athletic performance. Obviously, we're looking at concentration of oxygen in the air and atmosphere. So if we have an increase concentration of other pollutants, that means we're going to have a less oxygen come into our body per breath. So areas of air pollution where carbon monoxide is high reduces the oxygen carrying capacity of the blood. Alright, so near roadways this is very high. Carbon monoxide actually bonds to hemoglobin instead of oxygen, and therefore we cannot get oxygen on top of those hemoglobin. So carbon monoxide poisoning is common sometimes, which means that if we breathe in too much carbon monoxide, we just simply cannot get oxygen into our system, and eventually it affects our bodies and can cause our brains to die. Okay, so here is the questions that you need to do based on this video and this unit. So everything follows on from page 148 to 155.